There was a time when a quiet stream could power more than a village's thirst. Long before wires stretched across cities and switches controlled entire homes, moving water carried something invisible, something people learned to capture without fully seeing it. Not as electricity in the modern sense, not as a grid or a bill, but as motion turned into force, and force turned into usable power. The strange part is not that this method existed. The strange part is how easily it was replaced by something far more complex. Today, when we think about electricity, we imagine power plants, turbines the size of buildings, and networks that span entire countries. If the power goes out, most people feel helpless within minutes. Lights vanish, devices die, and suddenly, everyday life pauses. We've become dependent on systems so large and distant that we rarely think about how energy actually reaches us. And when energy becomes a problem, the solution is almost always external. Buy a generator, install solar panels, pay higher bills, or wait for repair crews. But what if power didn't have to be distant? What if small, simple systems once allowed people to generate useful energy right where they lived, using nothing more than water, gravity, and basic materials? This is where the older method becomes more interesting. In many traditional communities, especially those near rivers or streams, people understood something fundamental: moving water carries energy, and that energy doesn't need wires to be useful. Long before modern electricity grids, water wheels were common tools. They didn't produce electricity at first. They powered mills, crushed grain, pumped water, and turned mechanical systems that made daily life easier. But over time, as understanding of energy evolved, these same principles quasi became the foundation for generating electricity itself. The idea was simple. If moving water can spin a wheel, and spinning motion can drive machinery, then spinning motion can also drive generators. This transition didn't happen overnight, and it wasn't always widespread, but in certain places, small-scale water-powered generators became practical solutions. Not industrial-scale dams, but modest setups, local, quiet, and surprisingly effective. The forgotten part is not the existence of hydroelectric power. Everyone knows about large dams. The forgotten part is how small and local it once could be. To understand why this worked, you have to look at the physics behind it. Water at a higher level has potential energy. When it flows downward, gravity converts that stored energy into kinetic energy, the energy of motion. The faster the water moves, and the greater the height difference, the more energy it carries. When that moving water hits a wheel or turbine, it transfers its energy, causing rotation. That rotation can then be connected to a shaft, and that shaft can drive a generator. It sounds mechanical because it is. There is no mystery here, just cause and effect. But the simplicity is exactly what made it powerful. In older setups, especially in rural or mountainous regions, people would divert a portion of a stream into a narrow channel. This increased the speed of the water, concentrating its force. The water would then strike a wheel or pass through a simple turbine, spinning it. Even without modern materials, wood and basic metal components were enough to create functional systems. Later, as small generators became available, these spinning systems could be adapted to produce electricity directly. But here's the part most people miss. The efficiency of these systems didn't come from advanced technology. It came from placement and understanding. People didn't try to overpower nature. They worked with it. They placed their systems where water already flowed naturally, where elevation changes existed, where the environment did most of the work. Instead of forcing energy production, they captured it. In many traditional settings, these systems were not designed to power entire households the way modern grids do. They powered specific tasks: lighting a few rooms, charging basic batteries, running small tools. The expectation was different. Energy was not infinite. It was something you used carefully, something you understood. This created a different relationship with power. Compare that to today. Flip a switch, and power flows instantly. But if something breaks, most people cannot fix it themselves. The system is too complex, too distant. The knowledge is not local anymore. So why did these small-scale water systems disappear? It wasn't because they stopped working. It was because larger systems became more convenient. As centralized electricity grids expanded, they offered reliability, scalability, and ease. You didn't need a stream. You didn't need to build anything. You just connected to the grid and pay for access. For growing cities and dense populations, this made sense. It allowed massive amounts of power to be distributed efficiently. But in that shift, something was lost. Local knowledge faded. Skills that once allowed people to harness energy directly became less common. Materials changed. Landscapes were altered. And perhaps most importantly, expectations changed. People no longer thought in terms of small, self-sufficient systems. They thought in terms of unlimited supply. This is not about rejecting modern electricity. It's about understanding the principle behind it, because the same idea still applies today. In certain rural or off-grid settings, small-scale hydro systems are still used. They are often called micro-hydro systems. The principle is identical to the older methods: use flowing water, create rotation, generate power. The materials may be more refined, the generators more efficient, but the core idea hasn't changed. If you live near a consistent water source with a drop in elevation, it may be possible to generate small amounts of electricity using this principle. But this is where caution matters. Working with water and electrical systems involves risks. Improper setups can lead to damage, inefficiency, or even danger. It is not something to attempt without proper understanding, planning, and safety considerations. In many cases, consulting professionals or using tested systems is the safer approach. However, even without building anything, there is a lesson here. Energy is not only something that comes from distant sources. It exists in movement, in flow, in natural processes happening all around us. Older methods worked because they respected those processes instead of trying to replace them entirely. There are also limitations to this approach. Not every location has suitable water flow. Seasonal changes can reduce effectiveness. Droughts can stop systems entirely. Maintenance is required. Debris can block channels. And small systems cannot match the output of large power grids. This is not a replacement for modern infrastructure in most cases. But it was never meant to be. It was meant to be enough. And that idea, enough, is something modern systems often overlook. The lesson is not that everyone should build their own power source. The lesson is that understanding where energy comes from changes how you use it. When you see power as something generated through effort, through natural movement, it becomes less invisible. You begin to notice waste. You begin to think differently about consumption. In older communities, energy was part of the environment. It was something you could see, hear, and feel. A turning wheel, flowing water, moving parts. It wasn't hidden behind walls and wires. And maybe that's why it feels like a forgotten secret today. Not because it was hidden, but because it became unnecessary in a world built on convenience. But the principle remains. Water still flows. Gravity still works. Motion still creates energy. And somewhere between the simplicity of the past and the complexity of the present, there is a quiet reminder. The systems we rely on today are built on ideas that were once small, local, and deeply understood. If this kind of forgotten practical knowledge matters to you, subscribe to Forbidden Vaults. Because the next vault opens another method modern life almost made us forget.